Okay, welcome back. So now we are going to proceed with the 1D bar problem, that is uniform bar second problem. So that is this is a problem. A load of 50 kilonewton is applied and shown in figure. Determine the nodal displacement, element stress and support reactions. We need to find. Take is equal to 20 into unit stress, 10, 20 into 10 raised to 3 Newton per meter square. And this is the problem they given. Now, what is the difference between this problem and previous problem? Previous first problem they fixed one end and they applied the load at the other end. But now they fixed here the load applied this point, and at point B dash to B there is a distance, that is gap is there, that is 1.2 mm, and here wall is there. Now what will happens when you are going to apply the load? So due to this load there will be a free movement B dash will, so that the end the bar will move freely up to distance of 1.2 mm. When come to this point, when point B dash move to B, what will happen? Then it can't be moved after that. Therefore, there will be stress will be developed. So therefore, uh, that is our difference. And now we need to execute in the same Ansys. So before going to execute in Ansys, how many elements we need to create? In the previous one they mentioned two, but here they are not mentioned that. Therefore, we can take up two only here. So here to here up to one element, and here to here two element. Therefore, three nodes and two element. Node 1 is 0, node 3 is 200,00, and node 3 is 400,0. So let me execute in the Ansys, and bar uniform area is 300. So go to as usual preference, then select structural, then press OK, then go to precursor, then element type, add, then go to select link, OK, then real constant, add, then we need to give a 300 mm square. Everything I'm giving in mm only. Then go to material property, material models. So what is the material E value? 20 into 10 raised to 3. Linear elastic isotropic 20 into e power 3 into x power 3. Okay, now let me close this window and go to modeling. Now we need to create a node, and therefore we need to create a node in FTCS. Yes, node 1 0 0, node 2 200, node 3 400 mm square. Now we we need to create an element by joining this node auto number through nodes 1 to 2, press apply, 2 to 3, press OK. Now solution, define loads, apply structural displacement on node, select node 1. So this is very important. Now boundary condition, there are three important boundary conditions will come. At node 1 it is fixed. At node 2 we are going to apply the tensile axial tensile load of 80 kilotons, and node 3 we are going to apply one more boundary condition. It's going to take up free displacement up to a distance of 1.2. Therefore we are going to apply that. So select node 1, press apply, then we need to constrain all the degree of freedom, then press OK, then select displacement again on node, select node number 3, and we need to select here it can take up the free displacement on x direction up to the distance of 1.2 mm gap. Now we need to apply a force on nodes, sorry, on nodes on at node 2. Press OK. We need to apply a tensile load of 80 kilo Newton. Correct, right? Yes. Yeah. Select node 80 kilo Newton. Press towards the right is plus. Okay. So now we complete a pre-processed part. Therefore we can go for solve, and let me solve this, then press OK. So we need to go for with general push to give the result. There are three important, one is reaction, stress and nodal displacement. Let me see the reaction now. Go to list result, reaction stage, and check out this 58,000 at, so here, yeah, at fixed end it is 58,000, at the wall side is 52,000 minus, same thing we got. So now we need to check the element stress. For that we need to define a table. Add, again come to here, sequence number ls comma 1, press ok, then close this. Where you need to see the result, this one, go to list results, element table data, and select this ls comma 1, press ok. See now, at element 1 193.33 newton per mm square, at node 2 minus 73.33. So let me verify this. See, element 1 193 minus it. So plus indicate element 1 under tensile, and minus indicate it is under compression stress. So now let me check the nodal solution. So nodal solution, click on list result, nodal solution with respect to x direction we are going to check. Node 1. Node 1 is 0, node 2 is 1.93, and node 3 is 1.10 displacement. So same thing, we are having this errors. So that means our problem is right. And let me through graphical we can use this contour plot nodal solution. Do you have, yes, okay, you can check now. Maximum is 1.93, that is one here at node 3, and node 1 is 0. Now to see the stress, go to element table, select ls comma 1. You can check now, element 1 is minus 73, whereas here, sorry, this is 193 and this is minus 73. So this completed the problem number 2.